Back when we were looking at raising numbers to the exponent 0, I made this stack of powers of 3. And we noticed that as we go down this stack over here on the right side, we're dividing by 3 at each step. After I finished that problem, I looked back at this and I thought, what happens if we keep going? Now over here on the left, the exponents just go down by 1 each time. So when we go down by 1 from 0, well, we get to -1. So on the left, we'll have 3 to the -1. Now over here on the right, we're dividing by 3 at each step. So if this pattern continues, we should get 1 divided by 3. Now, dividing by 3 just means multiplying by the reciprocal of 3. So over here, we just get the reciprocal of 3. So it looks like 3 to the -1, if this pattern continues, is just the reciprocal of 3. Now, also when we were looking back at those raising numbers to the 0, we looked at an exponent rule. This is the rule we looked at, and we thought about what happens if x and y are equal. Well, let's try to use this rule to look at what happens when we raise a number to the -1 power. I'm going to choose x and y very strategically to produce a -1 over here. The easiest way for me to do that is just stick a 0 in here for x, and I'll pick 1 for y. So what we're doing here is we're just examining what would happen in this rule if we let this rule work when y is 1 larger than x. Well, over here we're going to get 0 minus 1. That, of course, is -1. Now a to the 0, that's 1. A to the 1 is just a. So now see that a to the -1 should be 1 divided by a. That, of course, just means we are multiplying by the reciprocal of a. And sure enough, we see that a to the power -1 is just the reciprocal of a. But what about raising to the -2 power? Well, when I find something that works in math, I like to keep doing that. So what we're going to do is we're just going to do the same thing. I found something that works here. We're just going to see if it works to see what happens when the power is -2 instead of -1. Now what we did before is we just let x be 0, and we chose y strategically so we get a -1 over here. Well, now we're going to choose y strategically to get a -2 over there. We're going to let y be 2, and this side comes out to be -2. So now we're going to see what this exponent law gives us if we let y be 2 more than x. So over here on the right, we'll still have a to the -2. A to the 0 is still 1. And when we divide by a squared, that's the same as multiplying by the reciprocal of a squared. And sure enough, anything you multiply by 1, that gives you back your anything. And we see that a to the -2 is the reciprocal of a squared. Now if you look closely at all these steps here, you'll see that we can replace all these 2's with 3's, and that'll replace all these -2's with -3's, and we'll see that a to the -3 is the reciprocal of a cubed. Similarly, we can replace all these 2's with 4's. We'll get -4's over here. We'll see that a to the -4 is the reciprocal of a to the 4th. We can replace the 2's with any positive integer. And we'll see why we define raising a number to a negative exponent like this. A to the -n is just the reciprocal of a to the n. Now let's take a look at a couple examples real quick. Let's try 3 to the -4. We just use our rule. This is the reciprocal of 3 to the 4th. All we're doing is just using this rule here. 3 to the 4th, 3 times 3 is 9, times 3 is 27, times one more 3 gives us 1 over 81. Let's try one more. How about -2 to the -3 power? There's nothing special here about a. We don't need to say a has to be positive. So we can use a negative number for a here. We'll just use our rule. We stick in the -2 for a, and we see that -2 to the -3 is just the reciprocal of -2 raised to the 3rd power. Of course, -2 times -2 times -2, that gives us -8. So this is the reciprocal of -8, and of course that's just -1 over 8. So we see our rule, it works when a is positive, works when a is negative, and when a is 0, doesn't work when a is 0. You can't take the reciprocal of 0.